Okay, welcome back everyone to Robotics 101, Training for Ag Teachers and Ag Tech Coaches. This is Andy Lindsay, and today we're going to continue from where we left off, thanks to some help from those of you attending. So that is with this script that we were running, and without the robot course underneath. If we turn on the script, the robot goes forward and then stops in the shade, which is great, except for that if the shade goes away, it moves on again. So I just wanted to kind of close the loop on that little part before moving on to our to following a road. So this script should be in the chat. And what you'll want to do is hit open first and make sure to get a Cyberbot template with Blink, and then open that, and then paste in from the chat phototransistor voltage stop in shade, this script that is currently in the chat. And then give me a thumbs up when you've got that ready with your robot. We'll just make sure. Good job, number one.
Hey, dumb question. If the
Never.
code or the script is in the Cyberbot, is there not a way to pull it out of the Cyberbot later on and get it back onto Python?
You know, I think I saw a script extraction tool actually. I'll have to go hunting for that and possibly follow up on email because it'll take some clicking around to find it. But yes, I did see a tool like that. Usually, well, it's about half and half. It depends a lot on which microcontroller and language you're using. But like I said, I did see something like that. And I think the reference was on tech.microbit.org. So as opposed to python.microbit.org, tech.microbit.org is the developer community for the microbit. And yeah, I saw something on there, and I can go ahead and look for that. That's a really good idea. If I'd had that utility, I could have, I could have just pulled the script that was in my bot out and been able to save it, but no, I wasn't able to do that. And so thanks for
Oh,
digging the script out and
I
pasting
am
it.
I'm 100% certain I am going to do that sometime in my learning right now.
Yeah, well, I've had a couple of learning experiences today. You'll see soon enough. For now, though, let's take a look at how we could get it to stop permanently. So like right now, it stops whenever the shade is there. But what if we just want it to stop and not continue if the shade, or if light comes back? So to do that, um, there is a statement, and I want to say it's break, but yeah, that is a keyword. So break will break out of this loop, and so we could add break here below stopping the servos, and then we could display something like maybe an X. Okay, so that should display an X after we're done. So the two modifications that we're making to this are under the if volts is below, and then you'll want to all use your own threshold because your sensors and light conditions might have a lower or higher threshold value than 0.75. So if you can remember what you tuned it to last time, that's good. We can also actually just leave it at like without the break. Here, let me make sure I've got this saved here. Copy, paste, and save. Okay, so now that I've got it saved, I'll go ahead and take these little additions out and run the script again. Okay, so send a microbit. So this is the same old script we were running, and what we can do is watch the voltage. And then as you cast shade over it, we can see that it's 0.71 right now, and then 2.5 normally. So for me, that 0.75 might be a little low. You know, I could probably get away with, say, 1.25 and have it still work. The idea is that we want to be, say, halfway or maybe 2/3 of the way from our ambient light value to the shade value. And so actually, I think I'm just going to do it at 1.0. And then when you run that, if it stops under the shade, then that's great. And then next, we'll go ahead and fix the little issue of having it not having it restart. We want it to just stop completely with these statements. And so I'll go ahead and paste this in to the chat so you can try it out. Okay, paste. Also, for anybody who might need it, here is the link to the presentation. And we are currently on slide 80. Okay, so how's everything working with that? Okay, I'm seeing one head nod. Go ahead and give me some thumbs up when you've got it stopping and not restarting. Good job. We've got 3 up.
Andy, I'm not quite sure what I did. I mean, I have the X, but it maybe is the light in my classroom is really dark, so it didn't move. When I downloaded it, it just showed up with an X.
Okay, so that would indicate that yes, the darkness threshold was exceeded right when it started. So the best thing to do for that would be to put the hashtag in front of break to take it out of the loop. You don't actually need to comment this display.show. It's just never going to be reached. And then you can rerun it and then hit the show serial button and kind of keep an eye on what voltages you've got.
I may have accidentally tried to turn the switch on and my hand was over the photo resistor at the time. So
Oh, yeah, that's one thing that will do it. So if you're, for example, reaching over it like that to turn on the switch, well, you're covering the photo transistor as well. Okay, anybody still need some extra time? Give me a thumbs down if you need extra time. Or you probably do. I'm just gonna hang out for a second. Just give me a thumbs up instead when you've got it working with the perma stop. And so remember, the idea will be that you're testing it here. So like since I see 2.3 in ambient and then 0.6 with shade, I know that if it goes below, say, 1 volt, that it's definitely shade and I definitely want to stop. So that's the thought process we go through to pick a threshold for the hey, I've reached the enclosure.
So I have a question. Mine's working, but if I have that display.show image no, it's showing I have a red dot error next to that.
Oh, let's take a look then. So if I uncomment break, uh, display.show, usually that's going to be capitalization. For example, like if image starts with a lowercase I, then you'll get the red dot. And what you can do is you can point at the red dot to get a hint, like see how it's saying it doesn't understand the word image.
Yeah, I just pointed at it and my tab was wrong. There was a small spacing in there that I didn't see, and I guess that was
Oh, so you had like a
showing it.
space right there.
Yeah.
Okay,
All right.
good. Nice catch. So essentially, you were able to run it, and instead of displaying an X, it threw an exception and stopped moving as a result because of the indentation, and probably displayed an error message on the 5x5 LED matrix display here. All right, so have we all got this running now? One thumbs up. 2, 3, 4, 5. Okay, well done, everyone. Let's see here. So what I would like to look at next is, thank you, Eric, or maybe that was Ruby, not sure. At any rate, what I'd like to do next is take a look at, and I'm bringing up the email here to talk about the obstacle course. Okay, so here we are with some emails from this weekend. So this was the obstacle course I had in mind, and you've got all the assembly parts for it. But because I got that to you in the middle of Saturday, it didn't seem realistic to ask you to have it ready for Monday afternoon. So what I instead was I just set up a printable course that you all could print. And then the idea was to just take a Sharpie and draw over the margin between the pages, because there's always a little bit that the printer won't print. And so for any connection, we want to have a Sharpie covering that white line between the segments of road. And then this is the overall course if you print the whole thing out and tape it together. Now, in some ways, this looks nicer than this course, but this course actually has some features. This rounded part right here can be part of an exercise in something called PID, or proportional integral derivative control, which one of the features of that kind of control is that the robot can sort of start to get the idea of this continuing curve here. It'll just kind of set itself on this curvature for a while until it curves into this part right about here, and then it'll keep going. So that there's some additional thought that went into this particular shape, but this one definitely worked out better in terms of printable pieces. And if you're not worried about demonstrating how the integration part of PID control can start to learn this curve, then this course is great too. Additionally, Ari, do we have the other course up yet?
In YouTube, yes.
No, I was thinking about the course. There's a
the printed one.
The printed the roll-up mat.
The mat, not yet.
Okay, so we'll hope to show you something cool that's kind of like this in possibly the next.
You can show it because we are placing the order. We should have it in 1 or 2 weeks. So if you had one, you can show it.
Yes, I think I do have it actually. Let's see here. Okay, my drive. Contest mat. Okay. So this is a contest mat that will be available soon. And what it has is a number of items that the vision sensor that we'll be building next workshop session can detect. So it can detect these little QR code looking things called April tags, and it can figure out that this is a potted plant, this is a car and a person, and it'll call this a TV even though it's a monitor, and it can detect the colors and then also see the road, but the sensors we'll be working on today can also see this road. Anyway, this is a nice little contest mat that is coming soon that you'll be able to purchase from Parallax. Okay, and so here is the mat, and what I have is, just for demonstration purposes, I have a little section of the mat, basically just a straightaway and a turn, and that's really all we need. So pages M and H, if anybody doesn't have that, just tape them together, and then hopefully you can see there's a slightly different darkness of stripe right here. So this is where I used a Sharpie to color in, and then the rest is out of a laser printer. It turns out that color printers, what the sensor is going to do is be shining infrared on this and then checking for a reflection, and it'll reflect off the paper but not off the toner black. Now if we instead use color printer black, sometimes the pigment that looks black is highly reflective of infrared, and so it turns out to not be detectable. So that's why I put a little thing in there about using a tone, a laser printer as opposed to a color printer. But we can check that, and if nothing else, just a couple of electrical tape stripes strategically placed so they would be under the QTIs or the sensors as they're spaced under the robot would also work. Okay, so with that, what I'd like to do is show you how some of that works. Okay, so here is a link to, oh, this is the infrared, sorry. So I guess I should just briefly tell you about the infrared circuit. We're not going to do that during this training, but what this is it's like whiskers, but without requiring contact. And so this is also, by the way, part of our convert your Cyberbot robot into a SumoBot that can autonomously push its opponent out of the way. And so if we go back to learn.parallax.com and then look at Cyberbot, Python, and then scroll down to the projects, there's QTI line following. And here I wanted to show you just a couple of things. I'll copy the link of this into the chat. There you go. Okay, so continuing into the, so normally, or if we're not following a road, if we're following a line, like a single piece of electrical tape that's on a piece of poster board, we like to use 4, and we can kind of keep the 2 in the middle centered on that. And so there's lots of wiring of the 4 sensors, and then they go with cables underneath the robot. So you normally use standoffs like this underneath the chassis. And then when that's done, we can test the robot by moving a line below the sensors. And with the script, it basically shows us which QTI detects the, or the QTIs are underneath right up front here. And by moving the line back and forth, well, whichever QTI did not see the reflection of the light it sent out in a certain in a fixed amount of time is it displays that it uses that column to display the detection. And so the way that we like to do it, remember I talked about APIs last time, and in this test script, and I'll be giving you a link to a slightly different test script in a little while, but this test script has a QTI module that makes it so that you can just say, hey, read all those QTIs, and they're connected to pins 7, 6, 5, and 4. And so read all those, and then we can figure out which ones have ones in them indicating detection and which ones have zeros. And so we'll go ahead and take all the ones that gave us ones and light up those columns. And so that's what this code is all about. So reading the QTI is a matter of, hey, let's go get the module that was published for the QTI and check how it needs to be used through documentation like this, and then we'll use that statement to test it. Okay, so with that said, here is the QTI kit that I thought I had spec'd out for you, but it turns out that I forgot to include these screws and standoffs right here. Well, we have some of these screws, fortunately, and we also have some other mounting hardware. So instead of using this mounting hardware, we're going to use some slightly different mounting hardware. And so the next thing I'm going to do is try to guide us all through using that mounting hardware to put our QTIs together. So what we'll need is we'll want to take a look inside these two parts of our larger kit. This is where the QTIs come and the cables. And then there are going to be a couple of metal brackets in here. There'll be one that looks like that. And then one that, this is a straight one that I bent, and we'll go through that. So you want to grab the straight bracket, which is this one, and hold off on bending it. And then the L-shaped bracket out of this bag. And then this might also be where we have some additional standoffs like that and that. Whoa. And what I'll have you do is grab all the parts. So bear with me while I move them out of the way here. Okay, so these are the two kits. And then our parts are going to be the 3-wire cables. So is anybody catching the background noise that I've got going on, or is that not audible to you?
I can hear it. I don't hear anything.
You can or cannot?
Cannot.
Okay, very good. My feline office partner is demanding to come in and swish her tail in front of the camera and whatnot. And so she's making quite the racket outside the door. So I am now putting the parts that we are going to have you gather hopefully in view. Some of these will be out of the main kit, like these nuts right here are coming from the original robotics kit. They're some of the unused. We mainly use the nylon lock nuts. So here are some leftover non-nylon lock nuts. And then we'll also need from this kit, there should be 2 nylon washers. And then last but not least, we're going to use some jumper wires, preferably 2 either yellow or blue, and then 2 red and 1 black. So these are all the parts that we're going to need for today. Okay, and go ahead and give me a thumbs up or text when you've got all those pieces ready to go. And remember that this bent one here will actually start flat. Okay, we got 1 thumbs up. Two thumbs up. Anybody need more time to gather parts? Give me a thumbs down if you need more time. Otherwise, please give me a thumbs up if you've got your parts. Again, even those of you who already have your parts. So I've got 1 thumbs up, 2 thumbs up, 3, okay, 4, 5. Okay, we are making good progress. 6. Can we get 7? Okay, well, give me a shout out if you need some more time. Okay, so what we're going to do, I'll go ahead and mute my video here. Okie dokie. So what we're going to do first is I'm going to avoid unbending and rebending this. But what we're looking for is to try to get this previously flat piece. Basically, what I did was I put my thumbnail below, basically just below the hole in the center, between well, I'll just unbend it a little and hope it doesn't break. Okay, so what I did was I grabbed a hold of it right about here, where the hole is in the center of the flat piece. And I just went ahead and bent it right around that hole to make it an angle bracket. It's not exactly the same size as this other angle bracket, but it's pretty close. Wow, that turned out to be really close. So, so yeah, try to bend it 90 degrees right at that hole that's in the center of the straight bracket to make it an angle bracket. And for this, we can turn off our robot supply. And we don't necessarily need to take anything apart at this point, because I'm going to have us mount it all up here. Okay, so what we're going to do next, I'll unplug my Cyberbot from USB for this, is and unplug the battery as well. All right, so what we're going to do is take the angle bracket that did not have a blue adhesive coating on it. So we'll leave that one for a second. We'll start with this one right here, the angle bracket that is shiny and does not have a blue side. And what we're going to do is attach it to the higher of the 2 holes right inside here. So we're going to take the 2 holes of the angle bracket and basically put the higher hole of the angle bracket on the higher hole here in the chassis. And so for that, we'll take one of these 3/8 inch screws and put it through. Again, we're going to put it through that higher chassis hole. And then we'll take the end with the holes. So this is the chassis hole that's closer to the to the top of the chassis. And then we'll go ahead and put the top hole through it and then have it hang down like that. And then we'll go ahead and use our screwdriver from the kit and a nut to fasten it. So that'll go something like this. Oh, yeah, I think I might want to use the little, see if the wrench will work on that. I don't know if the wrench will hold the, oopsie. Okay, well, at least if I put my finger under it, it'll give it a good purchase. See if it holds it. Yeah, it looks like it's going to. And then we can go in here and use the screwdriver to turn the screw and then tighten it down. And when we're done, it should look like this right here. And we're going to do something similar for the other side. And for that, we will also want the longer end. So the shorter end is mounted to the top hole here. Then the longer end is coming out. And so that's essentially the same thing we want on this side. So we're going to take the shorter end of the bracket and again, the screw is going to go closer to the top of the chassis up here. And then go ahead and attach it. And we'll want to bring it to roughly the same height as the other one. Next up, we'll so we'll want to mount these standoffs here so that they are, let's see if we can get back into focus here, so that they're pretty close to the edge of the chassis. So like roughly, here's one of the standoffs. And so the idea will be to take our QTI and put it on the 7/8 inch screw so that the parts are sticking up. So what I have here is the screw head, and then we can also see that the header is sticking up on this side, and that there are some little tiny parts under this QTI label. What we do not want from the top is to have it is to see this side instead, where there's no parts and no pins sticking up from the header. So we want the pins sticking up. We want to see the head of the 7/8 inch screw. And then we want to see some little tiny parts soldered onto the printed circuit board. Then we'll go ahead and put the one of the nylon washers on there. And then last but not least, we'll put the standoff on there. And then we'll have the nut ready for when we attach it to here. But first of all, I need to hear where everybody is at. If you could unmute yourself and let me know if there's something you'd like to see me do a second time, or just give me a thumbs up if you're exactly with me. 1, 2 thumbs up. 3. Good job, everyone. 4, 5. Okay, 6, 7. Oh gosh, all right. Okay, so before we attach it, I want to double check and make sure that you can see the top of the screw head. Come on into focus. That you can see the top of the screw head, and then the pins coming out of the board and some little tiny parts here. And then underneath, we're going to have that nylon washer, and then the I think this is a 1/2 inch standoff. And then coming out the end, we want to see the rest of our 7/8 inch 440 screw. Okay, and then what we'll do is we'll put it on the bot, and for now, we might decide to turn them around later, but for now, I want it so that the pins are sticking forward toward the front of the bot. And then we'll use, and then again, you want to have it toward as close to the wheel as possible. And see if I can get this with the wrench. So like that. Next up, we'll do it for the other side. So we've got the second QTI. where we want to be looking at the top side that has the pins coming upward out of it and the visible parts right there. So we'll drop the screw through so we can see the screw head along with it. Okay, then the nylon washer comes next. And then the 1/2-inch standoff. Like so. Then grab a nut with the wrench. And then attach it as close as possible to the wheel on the other side with the pins sticking forward. So there I am, close to the wheel as I can get in that slot. And then I'll loosen it a little bit and just try to set it up so that when I tighten it, the pins are forward. That would be a good angle if I can get it to sit that way. Okay, is that helpful? Hopefully you can see to build that. Go ahead and give me a thumbs up when you've got that set. Okay, we've got 1, 2, 3, 4, 5, 6, 7. This is pretty amazing. I'd probably only be halfway into it if I were in the audience. Okay, well done, everyone. So what we'll do next is go ahead and take a short break. Let's make it a 5-minute break, come back at 10 minutes till. So it's currently 4:45. We'll come back at 4:50. Okay, welcome back from break, everyone. So we've got the mechanical part of our QTIs done now. And what it should look like, let's see if I can find a box here. So I'm preparing a surface to have the bot visible to the camera. So this is what it should look like. See how the QTIs are, roughly 1/4 of an inch above the surface. So essentially the sensors are right here, and the sensors are probably actually a little more than 1/4 inch above the surface, and then the bottom of the little plastic headers are maybe 1/4 or 3/8 of an inch above the surface. Is that about what you all have, and are they about equidistant? Both of them are roughly the same height above the, because they're both connected through the top, through the, basically if this is the top of the robot, even though it's the bottom of the screen right now, essentially we've attached our L brackets, the short ends of our L brackets closest to the top of the chassis here. And then we're as far out as we can be on both of the L brackets. And then they're roughly, again, equidistant from the surface of, if the robot's sitting on a surface. So is that pretty much what we've got, hopefully? Okay, give me a shout if you need, if we need to hang on for a second, but otherwise, what we'll do next is wiring. And for wiring, okay, how's that look? Can everybody see? Let me move my chat out of the way so that I can see. Are we good for being able to see the top of the robot here? Zoom keeps on bringing me back to another screen. Okay, how's that look? Is it fairly clear? Okay, I've got some thumbs up. Excellent. Give me a shout out if you're having trouble seeing any of this. The next thing we're going to do is we're going to grab our 3-pin headers. So I'll set them on the just this area for now, just to give you a chance to grab them. So these are the 3-pin headers. Or maybe like right here and there. So this is a second set of 3-pin headers that should have been in the pink bag with the QTIs. So we're looking for these 2 3-pin headers. And what we're going to do is we're going to plug them in, and what the rows we want to select are basically the second column top row. So see where I put that right there? I've got it so that there's one open column to the left here. And then I've got the QTIs started on the next column, and it's at the top row of the white breadboard. So we do not want a pin going into this black 3.3 volt header. We just want 3 pins into the top row of the breadboard. And so once you've got that started, go ahead and press it all the way in. Okay, next up, this will be the tricky part. And that is that we want the top pin of the next 3-pin header to be in the same row as the bottom pin of the 3-pin header we just plugged in. So it's going to look like this. And again, I'll let it sit there for a second. So hopefully this is visible that that this top pin here is in the same row as the bottom pin of the other 3-pin header. So that's crucial. Well, we could work around it, but to make things go smoothly while we're wiring and testing this, it'll be important. Okay, so once you've got that 3-pin header lined up, go ahead and press into the board too. And then hopefully now it's fairly visible on the screen that the third row from the top has a pin from the lower 3-pin header going into it and a pin from the upper 3-pin header going into it. Not sure if I can get any closer and keep the focus. How's that look? Okay, so once you've got that set up, what we're going to do is that row that has two common pins, we're going to give it a common ground by connecting our black wire as the third thing in that row. And our black wire is going to go clear down to the GND, the black GND or ground sockets that are below the breadboard. So what I just did was I connected the black wire to the third row down where the two pins from the upper and lower 3-pin headers are. And so it's taking that and it's jumpering down to the ground pin right there. Now the outermost pins are going to go to 5 volts. So basically what that means is that we can take the very top row that also is with a pin, and if you see this 5V label up here, we're going to plug that into the 5V black socket. And we'll do that for also the very bottom pin on the bottom row here. We're going to take one of the sockets from that row and also jumper it up to 5 volts like that. And last but not least, we'll connect the we want to connect to IO pins, and I'll go back and explain why we're doing this. But this is something that we typically give the students a diagram. It's not identical to this one. We're using different IO pins in the student activity. The reason I chose these is because that way we can have these out of the way when we're adding the Husky lens. Okay, so what we're going to do again is the top and bottom pins go to 5 volts, the 5V sockets. The pair of middle pins will get a wire that goes to ground, GND. So that's the middle pins that are shorted together on a single row. Then the middle pins of the 3-pin headers, so that's the second row and the fourth row. The second row pin will get jumper to P15, and the fourth row pin will get jumper to P14. Looking for a way to get that black wire to show up. I think that'll work. Okay, so go ahead and double check your wiring. Also, I noticed that I squished some whisker wires together. That's not necessarily going to be a concern today, but it's best if you keep your whisker components from touching each other. Component leads, I should say. Okay, so how are we doing? Do we all have what looks like a passable version of that circuit built up? One thumb up. 2. 3. 4. Is that a 5? Looks like maybe 5. And I apologize, I actually had a couple of people covered, so I don't know whether we had a 6 and 7 there, and I just didn't see it. Again, give me a shout out if you need more time. Okay, so the next thing we're going to do is we'll take the lower 3 pins and we'll push our 3-wire cable so that the pins that are sticking up sink into those 3 sockets, and we want them to sink all the way in down to the little plastic header. And before you do that, make sure that the black wire is close to the center. Or rather that the black, essentially that for this lower one, we want the white wire at the bottom and the black wire at the top. And then we'll plug onto the lower 3 pins. And make sure that you're not accidentally 1 pin down. You want to have all 3 pins inserted into their corresponding sockets. Okay, so now the QTI on the right side here says WRB. It was in focus for a second there. There it is. WRB. So upstairs we have BRW, black, red, white. So essentially what we'll need to do is give this cable a half twist so that the white wire is up top as we put it onto the QTI. So hopefully it's visible now that the white wire, it goes white, red, black on the QTI that's on the right side of the Cyberbot, but that we have black, red, white on the cable up top. Okay, with this second wire, what we'll do is the reverse. Since remember that there's 2 shared pins, and I mentioned that we want to have a common ground. And so what we're going to do is have the black wire in the 3-pin cable. That's right here. Go on to the row with the shared pins, and then the white wire will be up top. So it'll be kind of like a mirror image of the first 3-wire cable. So the 2 black wires are now shorted together and connected to ground. And then the red and the white wires have their own connections. And don't worry that the yellow wires here end up connecting to red. There's a long development story background behind why we're using the center pin for signal. And it's a lot of it has to do with legacy. Normally we would use the white pin for signal, but these guys are using the white wires for power, and then the red wires in the cable here are going to be the ones that get information from our QTI sensors down below. So this one, we are not going to give a half twist. We want to basically have the white wire on the top, the black wire on the bottom, just as it is down here. So, so again, from top to bottom, we will have white, red, and black down below for both sides. But up top, we've got the little mirror image going on here. And so this, pardon me, this lower cable has a half twist in it. Go ahead and give me a thumb up when that all looks ready. And then we'll proceed to testing. So I've got 1 thumb up, 2, 3, 4, 5, 6. Fantastic and excellent work, everyone. Okay, so now is the part where we'll need at least 1 piece of paper from our printout. And we'll need a script too, and I'll get to that in a minute. So as you can see now, we're almost to the edge of the road on both sides, but not quite there yet. And there is some room for adjustment too. Like if we wanted some more, wiggle room or slop room, we could take these QTIs and adjust them inward a little bit. But for now, I think this will be fine. So the next thing I've got for you is a link. So this is Cyberbot Sumo test QTIs.hex. And so that is one where if we paste and go, we'll end up at one of these Google Drive, no preview, but you can download it screens, and we'll want you to download it. All right, so with that said, here is the link. Let's see, so we'll save this one and then open no. Cyberbot Sumo QTIs, there we go. Don't worry about these errors. They are a confused syntax checker. So now we can open it. So after you've downloaded it and opened it with the Microbit Python editor, go ahead and send it to, so we had, I had disconnected and cut power. So what we'll need to do is plug the barrel jack in if you unplugged it like I did. Set the 3-position PWR switch down here to the middle 1 position so that you've got one of the 2 lights on, and then reconnect the USB cable. Then once you've got that done, loading it into the microbit should be fine. And we won't need anything from the serial display. So what we should see, and again, this is a thing where these are fading in and out, but they're solidly on my Cyberbot. And so what you want is, if your QTIs are over the road, let's move it a little bit this way so it's better centered. If your QTIs are over the road, you want to see both indicator lights that the road is detected solidly on. So this might be the part where some of us have to do some troubleshooting, because it's easy to get some of these wires in the wrong bomb site, or possibly have a backwards, one of these 2 cables backwards and whatnot. But if you do have 2 solid lights with both QTIs over the road, if you move one QTI off the road, the corresponding light should turn off. I guess I had to move it a little further for it to turn off. I was still too close to the road, but now it is definitely off. Meanwhile, this is still on solid. And then if we move it to the other side, so that this QTI is off the road, and it looks like we really have to move it further off. Now, I might have a problem here with this particular QTI, because it is still on for me, and I don't want that.
Yeah, mine are staying on also no matter where I am on the road.
Okay.
No, I flipped my paper over and I pushed it in almost under that tire and it went off. But any other position, it hasn't.
Okay, that's
Stays back
interesting,
on.
actually.
I found that if you point the front of the robot closer to the ground, then it will work on the black. You know, it will sense black or white, like light will turn on or off. So if you tip the
Oh,
nose of the
interesting. So you
robot
need them a
down,
little closer to the surface. So we're still too far away, you're saying?
I think so. So like on your robot, just try it. Just tilt the nose down to watch the lights.
Okay, so
Yeah, when I did that, mine worked too. So I think we're a little too far away.
okay. Yes, because I can see now that I'm tilted forward. Well, I do get an occasional detection. So if we're pointing away at infinity, we've got our lights on. And then if you put your finger over, say so I'm putting my finger over the detector. I'm not pressing on it. I'm just like barely touching it. And so the right light is off, and then I just took it away. And now I put my finger under the left light and it is off. So first of all, we want to make sure that we've got that good. And then we'll see about how to adjust this. So if you have to be close, I wonder if I'm going to switch over to the 3-volt supply. I don't think that's going to give me the desired result, but just in case, I'm thinking about it backwards. Yeah, so that made it worse. So now I have to be really close. So yeah, 5 volts is definitely the right spot.
Looking at my bot, I only get the right side.
I'm sorry?
On mine, the right side will do it, but the left side's not having it wired exactly how you have.
Okay.
And trying all the tricks too. So I don't know if is it that shared port? Like is that
well, the one that's a what it's called is a common ground.
yeah.
So yeah, we definitely need to have both of the pins that are connected to the black wires here. So those both want to be on the same row with the black wire that's running to ground to give it a common ground. And then each red wire where it connects into a row is going to go to P15 and P16, and that's going to be in this black header. So the port labeled P15 and the port labeled P14 are the ones that are going to the red wires.
Oh, it's 14, not 13. I think you had.
Oh, I may have said 13
There
by
we go.
accident. If
That
so,
might be
I
what's going on.
apologize. It's 14 and 15 for this
Okay.
test script.
That could be why. Problem solved.
Okay, excellent.
There it
So we know the sensors are working and that I just didn't get them close enough to the surface. So interestingly, wonder what'll happen if we just tilt both of them forward, see if that gives us anything. Okay, that actually, on my bot, that completely appears to have solved the issue. So all I did was see how my QTIs are tilted a little bit forward now? Probably at about a 20 to 30 degree angle. That gave me nice solid detections of the white paper on the periphery. So I'm actually going to tighten them both so that they stay at about that angle.
That wasn't quite close enough for mine.
Really?
I'm gonna keep playing with it, but
okay, because yeah, it's going to vary based on your printer ink, and how black of the surface is. You might also, if you have a Sharpie nearby, you could try different angles, and try different. If you have like a spool of electrical tape nearby, you could try just a little piece of electrical tape and see if that works. Otherwise, roughly that angle should work. And then really what you can also do for homework to just make sure this is running well is to disassemble the whisker circuit, and that way you can grab an extra nylon washer and add it to the standoff, and that'll put your QTIs closer to the surface. So some combination of that extra QTI plus putting them at an angle, and This is very solid, because again, this is staying solid for detection, even though on the camera it appears to be fading in and out. But it's very responsive as far as its detections go.
Are we going to need the bottom hole? Because we put the screw in that top hole on the frame. Mine, I could get it to fit on the bottom hole and still not drag.
Yeah, I was worried about having it be too close, but
I kind of
so
had
are
to
you
angle
asking?
it out, but
Yeah, if you're asking to adjust essentially the way it's attached here, yeah, that's fine. I mean, if you've got a distance that's working well for you, um, and it can be pointing straight down or at an angle like I've got it, either way is fine. But if if you have a way of moving them both, scooching them both down a little bit, that is fine. I guess another thing you could do is temporarily remove the little rubber tire. That'll drop it a little bit too.
The nylon washer that goes up against the QTI,
Yeah,
does that insulate for continuity, or is it there as a spacer?
it's just there as a spacer. So for example, if you needed the QTI to be riding higher, you could remove that nylon washer.
So I flipped the bracket over and I ran the long side of the angle out of the top hole.
Uh-huh.
And I think that if I pull out the nylon washer, I think that'll get it just barely clears the. I think that'll work too.
Okay. Yeah, previously I had challenges with having it too close, but it sounds like I got it too far away, and I'm sorry about that. So what I will do for homework is basically I'll leave you to go ahead and uh, first of all get it so that it's responding reliably, and then what you can also do is you can try just experiment with the next program that we're going to run to tune it to see what is most responsive and how much speed you can get away with while navigating the course. So we don't want to basically if the robot leaves the course and gets lost, then you know that either it's going too fast or you need to possibly turn more sharply, various things like that. And so let's talk about the script that you can use to do that. That's going to be the second script. So it's the pavement follower.hex. Copy link address. Paste and go. And download. So we'll have you do that for those of you who have got it. And I'll just demo to show you what you'll be looking for as you're prototyping with it. Okay, so here we are with the obstacle course, and you won't want to start this until you reliably have the light. It should turn on and stay on when the sensor is above the black surface, and then it should turn off and stay off when the sensor is above the white surface. And that has to be the case on both sides. And once you've got that testing out good, then what you can do is open up that pavement following. And so this is all the same detection stuff here. And then it has a Cyberbot nav. And what this is going to do is it's just going to make your maneuvering easier. We wrote a function like this during the first or second workshop session. We had one where we could use positive speeds for both wheels for forward and then a duration. And so I'm making this duration 1 so that essentially this while true loop is going to grab the QTI values by calling QTI detect, which is this thing up here. And so it goes and it loads up the 1 or 0 in QTI-L and the 1 or 0 in QTI-R. And then we're basically saying, well, are they both 1? Well, that means we're over the pavement and we can go forward. And I'm doing this very slowly at first. And so it'll be your job to maybe speed it up as much as you can. Remember, 115 is top speed. And then take a little short video for turning in later of it navigating a course. And for the course, if you don't want to put the whole thing together, again, just something like this is fine. And so if we run this, send the microbit, and then set it to, so I started with very slow speeds just because I want it to not run away from me. But as you can see, it is taking the turn. And now it's getting stuck at the end. And we could add some extra code to have it, maybe turn around and continue the other way. Students in my robotics class end up getting an obstacle that the whiskers bump into, and then the bot has to back up and make a semicircle and then resume the course. And then also they have to follow the course to the garage and then have it park in the dark by using that break statement in the loop when the voltage is just so with this photo transistor. So again, here we are following the track. And then what you can do is, try increasing these speeds. So like if we double all the speeds, we'll see if it can still stay on the road. Okay, so we'll start back at the beginning here and turn power on with this higher speed version. And then it makes it to the end of the course a little bit more quickly. And so you might even be able to get it to go 115 without really much in the way of modifications. I like to set the forward speed here to 115 and see if I can get away with just that and leave the turns as they are. Oh, I left the power switch in 1. Yeah, so it looks like it's doing okay. And you can tune it to, deviate less far from the road by increasing or decreasing the turn value. It might turn too hard, in which case you decrease these turn values. Or if it doesn't turn hard enough, then you would increase the turn values. And so that'll be your homework, is just to tune this and get it going and take a little film of it. And then with the next session, we'll move on to the Husky lens. Now, we're not done with this session quite yet, But I just wanted to let you know that that is what the homework is. Has anybody else got any line following success or road following success, I should say?
Andy, mine will start on the straightaways, but when I went through that little kind of S turn, it seemed like it just got locked up and it kept kind of moving back and forth in one spot. Is that
That's
just maybe my
interesting.
lighting or?
Well,
Yeah.
usually what that means is that both sensors have left the road, and so it's backing up, or that's typically what it means, because
Right.
basically when both sensors leave the road, that's when we're both zero. See how essentially now now both sensors are off the road, so both lights are off. They're essentially, the QTIs are returning zeros. So that's this one where QTI L is 0 and QTI R is 0. And let me see if I can add a diagnostic version of this.
I'm going to increase the speed and see if that helps.
Yeah, duplicate, and let's see.
I think mine was from shadows because mine's doing the same thing, Steve.
Oh, really? It's seeing it, it's having trouble with shadows?
It's like throwing itself off when it gets to a corner, but then it like tries to autocorrect and then it keeps throwing itself to the opposite direction instead of bringing it back towards the actual map.
Okay. Now, what numbers do you have?
For what? Oh, I went to 115.
Okay, yeah. So 115 might be a bit much then. so if you can take it back to say 30 and have it follow the course, that's a starting point. And then like tuning these numbers, like if you have 115 for all of them, yeah, it'll probably overcompensate.
No, I just have like exactly how yours was, I think.
Oh, okay.
The problem I'm having though too, it's like getting to a corner and then it's spinning itself around in the corner and then flipping directions and going the other direction. So I don't know if that's print quality or.
Yeah, it could be the print quality. It could be the lighting. It could be once you get your QTIs closer to the surface and then back underneath the robot, that it'll be more reliable as well.
Gotcha.
Let's see here. So if I open the test QTIs, oh, we are displaying the pixels anyway. So you'll be able to see what the bot sees through the display up here. And so keep an eye on that as you're doing the turn. But I would say, like, if we start with 60, let's see if this is safe for some speed, but not too much. Whoa. Yeah, so make sure, like with 60 and 50 for the turns, that it can navigate the course.
And I'm still having trouble getting this thing to recognize. Like sometimes it recognizes, sometimes it doesn't. I tried the disconnect feature. I was having relatively good luck, but now it's back to like the computer recognizes, it knows something's there, it all auto pops up, but then I get the no microbit found.
So one thing is, if you have a pair of tabs like this, if you try to load it from this other tab, that can cause trouble. If you have and especially if you've got the serial monitor connected, that can end up having it so that another tab cannot load the script to it. So generally, if you close one tab and then unplug, turn power off. I mean, in a worst case scenario, unplug, turn power off, plug in the microbit, and then plug it back into the socket. I've had some students with laptops where, for whatever reason, that was the magic combination to get it to come back. And then you can try moving the switch to on and see if it cooperates.
Yeah, I only have one Python editor open. I mean, if I close it, I guess everything's still, I guess like if I do close out of microbit, it's fine. And then when I reopen it, it comes back.
Okay.
But to have to close it every time is kind of.
Yeah, that's no good. What we can do is search at microbit.org and see if there's a description of that. And we can also, and in fact, you can email directly to support.microbit.org. I'll put that on this, or no, I'll put it in the chat. So it's, let's see, it's support@microbit.org. Let me check to make sure that that's correct. I believe it is. Okay, so microbit tech support email. Yeah, there's a support.microbit.org site. This is nice. And so like if I go to the root of support.microbit.org, then I better back up here. So here is how to open up a ticket. So I'll go ahead and paste this one in. So that's the address for opening up a ticket.
Okay, I'll check it out. Thank you. Because now
You're welcome. And I'm sorry that's happening on your computer. I'm not exactly sure. Just out of curiosity, are you using Chrome or Microsoft Edge?
I think I'm on Chrome.
Okay. If you have Microsoft, do you have a Windows machine or a Mac?
Yeah.
Windows. Okay. One thing you could do is if you have Microsoft Edge on there, you could try it too, just to see if it behaves any better.
Okay.
It used to be things like smartboard applications that used a serial port tended to handle the ports incorrectly and interfere with other devices. Lately, that hasn't been a problem, but I guess every once in a while there can also be some other driver that's designed to talk to something that you connect to your computer that could be causing some trouble. But yeah, I would just open a ticket and make sure to explain that you're using python.microbit.org and describe the reconnect challenge, that when you disconnect and then reconnect the USB. Oh, that is another thing. One thing that might help is before disconnecting, what you can do is hit the 3 dots. Okay, so right now I am disconnected. Oh, wow. Maybe I'm just repeating your symptoms here. Okay, so let's try plugging back in. Try again. Okay, there it is. Okay, so now I'm currently connected. So there's 3 dots next to the send to microbit button, and you can click those and select disconnect. And that might help before you disconnect the port. One other thing that might help is if you have, you could actually even right click your microbit and select eject. Okay, so that would completely remove it from, so it's disconnected from web USB here, and now it's disconnected from the operating system here. So it might be that if you do those 2 things before disconnecting, then when you reconnect, yeah, so it gives me the option to connect, but I don't see it. Well, interesting. So now, having done those 2 things, I'm actually seeing the symptoms that you reported.
So I'm not
There we
crazy
go.
because
There it is.
it's weird because I got it back on now. It wouldn't work on Chrome. I had to reopen it in Edge. The first time I didn't notice it. Then I like unplugged everything, plugged it back in, and then now it's back.
Okay.
Yeah, pretty sure I'm connected now.
Okay, and yeah, let us know if Edge turns out to be more compatible. This does tend to vary by computers. There's little subtleties in the way that the USB ports work. I don't really know the details, but I am aware that it seems like certain computers tend to be less forgiving about disconnecting and reconnecting to the microbit, and it seems to follow the computer more than anything else, the computer hardware. Okay, so I'd say that's about it for today. I think you all did a really great job. And like I said, go ahead and see if you can adjust the distance. I really wouldn't I would avoid initially getting closer than 3/8 of an inch between this sensor, it's right about there, and the surface of the paper. You can also try parallel strips of electrical tape. The vinyl on electrical tape is fantastic, typically at absorbing infrared, and so that will cause a detection or cause it to detect when other things won't.
Andy, what I did just now, I just used a Sharpie and I went around the edges and it works a lot better.
Oh,
So I
that is a
think
great
I
idea.
might have just printed them out bad.
Yeah, some of if you've got a printer that's a little tired and it's giving you a lighter gray, for example, where we're hoping for the black, yeah, that can do it. And so, yeah, going over it with a Sharpie may improve your detections. And then something like this, which I got at Staples, is really great.
Look at that tape. What is that tape? That looks like a
Oh,
roll with
hey.
lines and everything.
It's children's tape. You can lay it on the floor and play like race cars and set up your own versions of racetracks. So you can just there.
That is really cool. Have you tested it? Does that work on your bot?
I've done it on my desktop right now. I haven't tried taping it down to the floor or anything like that, but on my desktop with a little strip or two, it worked just fine. You have to double up the tape so it's wide enough because your QTI sensors are on the inside of the black, not the outside of the black. So you have to twice the thickness to make it
Yeah,
match.
and then you
But
also want to Sharpie over those white lines so it doesn't get, doesn't think it's off the road by detecting the
Could you
white
swap
lines.
that, Andy, to make
I'm
it
sorry?
detect? Could you swap that to detect white versus black instead?
Well, that's a really great question. So let's give that a try. So if I change all my ones to zeros here and vice versa,
Right, because that should fix it, right? If it's looking
yeah,
for
if we have a black perimeter and a white track to follow, now so we'll do it like this and see if it turns here. Okay. Send the microbit and then on. Great question. It totally works. Yes.
that'll be my homework. I'm gonna play around to see what happens if I just put one strip down and run it down the middle and steal your code or your script.
Okay. Yeah. By all means, I can. You want me to paste this into the?
well, and now too, couldn't you keep it in like a cage? Now it can't leave the perimeter.
Yeah.
So like
Now,
it'll
what
be
I
stuck
would
in the
want to
infield of the
do
racetrack
though
now.
is like just one strip of electrical tape. It might pass it, and then kind of go back and forth. Even like if you do a single strip of electrical tape, that will also work. It'll just kind of bounce back and forth um, as it's following the electrical tape, and that's where using the 4 QTIs gives us nice high resolution on following the electrical tape. This is a little clunkier, but it's still, really fine for making up a course. Um, yeah, in one of the labs I taught in recently, there was a dark carpet and masking tape, and even that worked. The carpet did absorb the infrared, and the masking tape reflected it, and so that was actually the same as uh, here, but with a white stripe along the middle. Would you like me to paste this in?
Sure.
Okay, copy and paste. And then it didn't send. Hold on. Send. There we go. Okay, so that's the adjusted version. And then let's see here. And yes, I think that is it. So go ahead and tinker with that and get the stripe following nice and dialed in. If you want to, you can also remove the whisker circuits, because we're going to mount the vision sensor on next time. And so I should not be doing that with a metal. So these the wiring for the whisker circuits, and then the whiskers themselves can come off. Let's leave the light sensor on. So that's an option, is you can remove the whisker circuits. I will also just kind of remove them as part of the demo for next time as well. Okay, so how's that for today and for your homework? We'll call that good. And then Ari, if you want to end the meeting.